Okay, right. So now let's just do a very quick summary of the entire topic. So we've covered the topic, yay, right? So this is not a very easy topic, okay, but I'm sure that if you do it step by step and if you are patient, you will be able to understand, okay, what's happening in this topic, all right? Okay, so we started off by talking about a circuit, right? So if you take a look, okay, you have a circuit and then the current actually flows from the positive to the negative, right? Okay, sorry, okay, let me just erase this first. Okay, so current will actually flow from positive terminal to negative terminal. So we say that this is the flow of the current, right? So even up to today, if we say current means flow from positive to negative. Okay, so what is this thing over here? Okay, this is only later on people realize that current is due to the flow of electrons. Okay, before that people didn't know. Alright, so people thought that current was due to the flow of charges that travel from the positive terminal to the negative terminal. But because we have been using it for so long, even up to now, when we say current, we will use it as the flow of charges from positive to negative, right? So later on, people find out that A is actually due to the flow of electrons, and electrons actually flow from negative to positive. Okay, so if it's in your questions, when you see questions, when they ask for flow of current, be very careful. Are they asking for current or are they asking for flow of electrons? Okay. All right, now then we talk about what exactly is current. So current is due to the flow of charges, right? Flow of charges, and current is actually equal to the charge divided by time, right? The rate of flow of charges, how fast the charges are moving. Okay, then next we talk about voltage, right? We say that before you can even have a current, you must have a voltage, right? And then that there are two types of voltages. One is the EMF. The other one is the potential difference. For EMF, it refers to the work done needed to push the charge around the whole circuit. For potential difference, it refers to the work done needed to push the unit charge through a component in the circuit, right? So EMF is referring to your batteries and your power source. Voltage is referring to, potential difference is referring to the components in your circuit, okay, like your resistors and your light bulb and so on and so forth. Okay, but you see that the formula is roughly the same. Alright, so you just need to remember one only. Just remember, I will suggest that you remember this one. Okay, you can remember it as voltage equals to work done per unit charge. Alright, next one. Okay, the next one is the resistance. Okay, we know that the current in the circuit depends on two things. Okay, it depends on the voltage, it depends on the resistance. The more voltage there is, higher voltage current will be larger. Higher resistance, wow, then the current will be lower, right? So current will depend on these two things. So how is these three things combined into a formula? It is combined into this formula R equal to V divided by I. Okay, resistance equal to voltage divided by the current. Okay, then we also talked about the resistance of a wire, right? And we say that for a wire, when the length increases, the resistance increases, right? So we say that when the length goes up, resistance goes up. When the length goes down, resistance comes down, right? Okay, then when we talk about resistance and cross-sectional area, we say that it is inversely proportional. Inversely proportional means opposite lah. Okay, when the area goes up, resistance comes down. When the area goes down, resistance goes up. Okay, so this is for the resistance of a wire. Okay, then we talked about a short circuit, right? So what is a short circuit? It is when you have a wire of low resistance and it bypasses the component in your circuit, right? So this wire of low resistance acts as a pathway for current to bypass the component in the circuit. So this can be dangerous since a large current flowing into the circuit may lead to high temperatures and may result in fire. Okay, then what else did we talk about? We talked about Ohm's law, right? Ohm's law. So in Ohm's law, what are we saying? We're saying that for a component, the voltage and the current passing through the component, if the voltage and the current passing through the component is directly proportional to each other. Directly proportional to each other means when I draw the V against I graph, or I draw the I against V graph like that, you will get a straight line that starts from 0. Then we say that these two components and conductors, they obey Ohm's law. What about conductors which look like that? Okay, so certain conductors, right? The voltage and the current, they are not directly proportional. So for this type of conductors, they do not actually obey Ohm's law, right? So conductors like this do not obey Ohm's law. Alright, so in terms of the summary of your notes, there you go, right? Okay, it's just these 7 points only that you need to remember for this chapter, alright? Okay, so remember these 7 points, okay? The formulas, okay, IQT, V equals to W over Q, okay, R equals to V over I. When the length goes up, okay, I don't sing again lah, okay? I think you're sian of hearing me singing already, right? Okay, and then finally your Ohm's law over here, right? Okay, so I hope this summary is clear for you.